Okay. Okay, let's continue with this silly thing. Hello. How are you? Complex things are interesting, right? Less boring than not complex stuff. Isn't that true? How are you doing? Good to hear. Good to hear. Yep, I'm trying to make a system that would generate a snowflake, which, as you can see, is not very successful yet, but hopefully I'll make this work. You like coding? Coding is fun. I like coding. I like coding where you can actually visually see something. This is interesting. Oh, okay. Then definitely just start practice coding. Ah, still young. You should enjoy being young more. You know, go out and have fun. Go play football. You know, exercise. It's not working. My advice is don't be afraid to explore different interests that you may have. Say if you like painting or drawing or singing, or explore as many things as possible. Like, don't reject what people try to teach you. Like, let's say maybe you don't like certain classes in school. Give them a chance, because they may be interesting down the line. You don't know what truly are interesting, and you'll find something that you like. And once you find that one thing, every day, just try to work at it a little bit more. And then 10 years, after 10 or so years, you have 10 years of experience doing that thing, and you just become great. And people don't even know how you have that skill, but you just secretly practice every day, So that's my advice for you. And don't do drugs. That's actually most important. Don't do drugs. Don't get into trouble. Don't get into irreversible trouble, But don't also shy away from, interesting experiences, Yeah. Although, even though I say this, when I was younger, I was just thinking I play a lot of video games, and I don't know if that is good or bad, but sometimes I do wish, yeah, maybe I could have used that time to do something else. But mhm, we'll keep doing that. Yeah, if you like it, then every day just try to learn something new. Actually, that's my advice for from today to the rest of your life. My advice is every day before you go to bed, try to learn something new, whether it's a new fact, new practice, a new skill, or just something new every day. Because we are a sum of our experiences, right? So the longer it passes, the more skill and experience you accumulate, and every day, just try to learn something new. You know, time doesn't go backwards, so you have to, really cherish that. You know, and I think when you're younger, time kind of passes slower, but when you get older, time really goes back really fast for some reason. So enjoy that sense of having a lot of time when you're younger, if you can. But try to learn something new every day, and you'll be amazed, 5, 10 years from now that, oh wow, you actually do know a lot of stuff. Yeah. And also make friends. I think that's also very important, right? Um, Practice social skills, make a lot of friends, see what other people are interested in and learn from other people. Um, and also another way to learn stuff, right? And if you really like math, for example, I'm assuming you're still in school, right? You have teachers, and you can ask your teachers to give you advice as well, or ask them after school, maybe can you show me something interesting or between classes, And I think old people are very willing to talk and tell you things. So, yeah. I think I gotta delete this part. This part does not work. I don't think I will need union. I think I will just iterate over the board here. Ah, I see. I see. Do you live in a big city in Brazil? Because I know that Brazil is kind of, there's a lot of a big difference between where you live. I don't know. Brazil is really huge. I know. Ah, well, then, internet really is a good resource. Um, so right now you're learning, I think, a lot of pre-algebra stuff. There's a lot of resources on the web. Let me see if I can find some. Mm, Let me see. What is this guy's name? Paul's Notes. Let's see what Paul's Notes gotta say. I see. I see. So there are a lot of these websites where people, a lot of different professors, and they made a lot of notes, and you can try to, I think this is a very good resource. Maybe you can check this website out. I have no idea who this person is, but he's written a lot of notes. For example, algebra, um, and then to talk about. I think you were talking about polynomials. Uh, and factoring, all that sort of thing. And you can use these for practice. I mean, of course, these are in English, but hopefully, um, you can figure out what they mean. Um, Solving equations, quadratic equations. This is the thing that you were talking about. Um, and there's problems and exercises, and you can look at answers to see if you get the answers right. So there are a lot of resources. I think this is a very good starting point. And this page also have calculus and more stuff, algebra trig review. And there's many resources if you search for it. Like and there's also a lot of these open textbooks. I think OpenStax is one of them. OpenStax. Let's see what they have here. If you click on subject, and there's math here, and then I think there's algebra, calculus, trigonometry, statistics, pre-calculus. Usually pre-calculus and algebra is pretty synonymous, but a lot of preparation for, let's see, table of contents. Just talk about functions and function notation. And do they have exercises? Because at the end of the day, what's important? You see, there are a lot of examples, and you can click on the show and hide solutions, answers. So yeah, OpenStax, this is also a very good website for a lot of free resources on learning stuff. Let me put it here as well. Ideally, in a perfect world, all these, what's the internet's wonderful is a lot of information is now freely available to everybody and accessible of information. So got to take advantage of that, Yeah. And actually, that's one, it's a kind of a scary thing sometimes to try to read other people's notes, but it is very nice because it gives you a lot of different perspective to see how other approaches. And of course, you don't have to overload yourself. Sometimes you get overwhelmed. There's so many resources, but it's good to just see how other people do it and just see various examples. It's always important. Math is certainly one of the subjects where it's all about exploring many different ways to see the same thing, and that's just what's beautiful about math. Mm-hmm. And here, there's other subjects too. Maybe you want to learn about science, astronomy. Ooh, astronomy. I think it'll be pretty cool. Like maybe satellites and planets, commercial. There's just so much stuff, that you can check it out. So this is like a project for, free resources for many subjects. Do you want to know the secret for coding? It's just by start doing it. When I was really young, the first type of language that I learned is called BASIC. Well, I don't know, basic programming language. Of course, right now, there's Java, C, C++, JavaScript, and all that stuff. But this is where I started. Basically playing around with this very silly program language called BASIC. In fact, it's called Beginner's All-Purpose Symbolic Instruction Code. And I kind of just follow through these booklets and then make very simple programs and try to understand how these things work. And you just kind of, play around with it, mess around. And anytime you don't know how to do something nowadays, you can always look up. It's like, for example, JavaScript. See here, I just ask Google, how do I check if something is in a list? and I just click here, and then people will explain how to do certain things, and I kind of learn from that. I never taken a class in coding or programming. I mean, no, that's not true. I mean, in college, I kind of had to take one, but I kind of already knew how to do it. You just have to play around. Real programmers learn how to do it, not from school, but just start playing, start messing around. And you can use this thing called one compiler, this website, to type in your code, and then you can just, this is like a playground, and then you can just hit run, and then you'll run. For example, right now I like to program in JavaScript. So for example, this will print hello world, like that, right? Or maybe I say for I less from 0, I less than 10, for example, I plus plus, right? So this is a very simple for loop, and I ask the computer to print out I. So this will ask the computer to print 0, 1, 2, all the way to 10. Let's see it. Oh, 0, all the way to 9, because 9 is less than 10, but 10 is not less than 10, so you stop at 10. And you just print these things out. And you kind of just play around with these things. And, there's all these different explanations on the bottom, but you just play around. And maybe start with this. Start with you want to make something. Maybe you start with a question. Hey, I want to make a program that does something. And then you try to figure out how to do it. If not, you can look online, or I think now there's also a lot of webs. I'll introduce you to this. On YouTube, there is this this guy called the Coding Train. Yeah, that is kind of scary.
This video is brought to you.
So, this is, I like this guy. This guy, kind of teaches you how to code, and is very friendly. And you can just follow along, I think maybe here there's some playlists that you can, depending on your level. I don't know what your level is at coding, but maybe there's very introductory stuff. There's many different subjects and topics that you can just click on it and see how things are done, and go from there. Right? What is an array? What is object-oriented programming? Introduction to distinct processing. And if you have an idea of what to make, then then you have a goal, and then that you will learn the thing that you need to do those things. For example, here's something that I made. No, not really. Almost never. Well, actually, that's kind of not true. When I was really young, I definitely went to the library and bookstore and flipped through some of them, but at the end it didn't, you just go home and just try it. So here's something that I made. I wanted to make some flower patterns, and well, I can combine math to do that. So all these things are drawn by some mathematical equations, and if I click this new one, it will draw a new one. So it's kind of a nice, interesting flower pattern, just for fun. Right. And I also wanted to make something where it will create some sort of like a circuit board type sort of thing. So I made this as well. And if I click this, you'll create a random circuit board pattern. So if you kind of have an idea, for example, right now I'm pretty interested in this visual type type of programming, a program that shows some very interesting visuals. So that's sort of that gives you an idea what to look up or what to try, right? So here it kind of generates a random, I'm of course these are not real circuits, but it's a picture where it resembles a circuit, and it's kind of cool. It just randomly makes one, you know. Yeah. So yeah, you just try. Get your hands dirty. Economics, not really. Not really. Like I do not have a deep understanding of it. I mean, just a very superficial understanding, not very deep at all. I mean, people who study, economics is a very complex subject because it's not just how monies work, but it's also a lot of psychology, and you know it's not easy because the basic moving forces of economics is still people, and people are very hard to study. Like people's behavior, that's not very easy to understand. So I try not to get into that. But I personally don't, even though I probably should. But if you do, you shouldn't do. You have to, you know, do you have to focus on more long-term type of investment. Don't get tricked by short-term investment. There's no such thing as getting rich fast. I mean, people sure say that they get rich fast, but that's just because they're lucky. But there are good long-term investments, usually with your bank, or with a good financial advisor. They know how to handle your money. I personally don't, but if you have a lot of money, you could try doing that. But if you do, I will recommend you do long-term investment where you are sure to grow. The purpose of investing in money is to insure against inflation. So here's the idea. As time goes on, prices go up just due to inflation. So for example, maybe bread today is $1. 5 years from now, it's going to be $2, right? So that's called inflation. So that means $1 today, it's going to be worth half of that in 5 years. So instead, let's say you invest your $1 and besides putting in a bank, because if you put it in a bank in 5 years, it's still gonna be $1. I mean, there's some interest, but the bank interest rate is very low. But if you can somehow invest in some diverse stocks so that in 5 years that $1 will grow to just be like $2, then you're catching up with inflation. So that's the only reason to really invest, is to catch up with inflation. And usually the market and inflation are related. Again, I'm not an expert, but that's an idea. Like the money in your bank, it's kind of dead. It doesn't do anything. But I personally still don't invest because I don't believe in. I feel like if I'm capable to work, I'll just work. Yeah. Game theory, yes. Game theory is a type of mathematics. It's a lot of decision making, but I'm not that much of an expert at it. Um, have you gone on more dates with your lady friend? Um, has school started already? I think Seattle semester system probably started, or is it quarters? Oh no. I'm sorry to hear that. What are you learning right now? Probably improper integrals or inverse functions? Or do you guys start sequences in series? It starts next Monday. I see. Starts with series. I see. Well, it should be exciting, you know. Uh-oh, why is it not working? Uh-oh. Is this too many? What the? This takes a lot of time to render for some reason. Let's see. I did. I went to college many years ago. 20 years ago. Is that right? Yeah, 20 years. Oh my gosh. Oh my gosh. 20 years ago. I do not have a computer science degree. I actually studied in college chemistry and physics. And after I graduated, when I was in college, I was also teaching. So I taught chemistry and physics during college as well. And after I graduated, I started to learn math and teach math. And then I went to graduate school for math. So so I guess I only have chemistry and physics and math degrees, but no computer science. Physics engineering 121. Sounds interesting. And what's interesting is when I was in college, uh, I took calculus and I said I will never want to take another math class that I don't have to ever again. But after I graduated, I realized, yes, I rather learn math. so, I started serious learning math quite late actually, maybe around when I was 23 or so. You know, but I wasn't that bad at math. It's just that I never really seriously studied it uh, when I was younger. I think when I was younger, all I want to do is play video games, which is questionable. So I guess I don't need any of this. How come you'll be doomed? You're almost done with calculus. Think of it that way, right? I teach math. I'm a math teacher. And I don't really prefer to do anything else besides teaching math. I guess I could simplify this. Oops. Cosine of pi over 3, of course, that is just 1/2. So why am I doing that, right? It's 0.0.5. And sine of this is root 3 over 2. So I should just do math. Square root 3 over 2. Does that speed up the rendering? Well, it's a little bit faster, maybe. Hard to say. Takes some time to do. Oh, just for fun, you know, just force of habit. That's just what I like to do anyways. So I guess it's both hobby and work. Unfortunately or fortunately, you know. Let's see here. Oh, I don't see anything. So is this the fastest way to do this? You are correct. Best way to learn is teaching. I highly believe that. Absolutely, absolutely. You know, absolutely. Mm. It's calculating this. Okay. Okay, so I guess 30 by 30, that's big enough. Let's start with this. Okay, then what do I need to do? I need to check a neighbor's cell state. So for each cell, I need to check whether it's on or off. So what what I need is I need to store these things in a matrix, I guess. What do I need to do? I need to store it as a how do I do this? I guess as an array of, let's say 60 by 60. Oh, let's start with that. Let's start with that. So, and they're all gonna be zeros first. Oh yes. So here's a matrix, and here is this linear transformation where this matrix. So here you see how this little picture, this little grid is sort of slanted, right? Instead of just straight up and down. That is done by matrices, actually. Right. So you see here, this little grid is not straight up and down like an XY, but it's rather like slanted at this 40, the 60 degrees, because I'm trying to make snowflakes, whatever I end up doing. So I want to have this hexagonal sort of symmetry. So you see how it's slanted, and that is done by a matrix, actually. This is done by this particular matrix multiplied by by old coordinate, and you get new coordinate, and that transforms it into a hexagonal type shape. Yeah. So I wonder if I have, say, A is an empty array, and can I assign negative index? For example, if I do negative 15 equals 0, what's going to happen? So what is A? So it will have an index. Okay. Okay. And then what I would do, so that's kind of nice, I think. I think that's what I like. So why don't I instead, okay, so basically something like this. And instead I do, so here I instantiate like that. And then like a startup company. Is that what you mean? Do you want to start one? Okay. Well, then you gotta first have an idea. And how do you get an idea? Is to first find a problem that people didn't know they need a solution to. And then make a solution for that. You gotta have an idea first, right? But once you have an idea, then okay, so here we have this 20 by 20 board. Maybe I'll do 30 by 30. Okay. Okay, so let's do this, and I do for X of M for Silicon Valley? No, I have not been there. Yeah. It's a different type of challenge, I think, coding. Oh, it's getting to fall time, so maybe it is nicer. Mm, let me do 2 times this. And then I would do floor. Okay, let's see what happens. Oh, whoa, this is interesting. Yeah, go back to in a different season. Maybe it's nicer. Okay, so what's going on here? If I do mx, what is m actually? Right. So m here is a 30. Oh, the length is 30. That's interesting. Better Call Saul. I'm not familiar. Who's the character that this person play? I guess I don't know actor's name. Oh, I think she's great. Yeah, it's kind of I mean, her character is in a tricky situation, you know. At one hand, you have someone you love, but then they're involved in very questionable things like what do you do, you know. Oh, that's tough. I think yeah, talk about math, not math. Oh, have you also seen Better Call Saul? Is that what Breaking Bad was? It was that meth? That was also meth, right? Yeah, yeah, she's a good actress. I think everybody acted very well, you know, in that show. It's a very good show. Uh, hopefully, we don't know if is there any more in this Breaking Bad slash Better Call Saul universe. Is there gonna be any more? You know, I think the directing and the story is all very amazing. Okay, so if I do x in m, also log x, what do I get? I do get all these indices. Okay. All right. And if I do console log mx, I should get a bunch of arrays. Okay. Well, you know, work hard and you will meet someone like that. Why? Impossible? Come on now. Nothing is impossible, right? Impossible is you gotta make luck. You gotta put yourself in situations where that will increase your chances of getting things your way, right? So go meet more people, go to social events, go to clubs, or take classes, talk to classmates. I don't know. Make chance, make luck, right? You can do it. Absolutely. Absolutely, absolutely. So here's a bunch of zeros and ones. But how come this is not uniform? Oh, that's a lot of ones. Why is that? $18.17. That doesn't make sense. Does that make sense? 60 by 60? 60 squared? Oh, no, that's about half. No, that's right. That's right. That's 1832. 1832. Yep, that's about half. No, that makes sense. So instead, I will ask it to plot XY. I mean, plot XY still work, right? So why is it not plotting correctly? Question mark. Something is bizarre. It's maybe just one pixel. This is weird. I should be getting more pixels than I should be seeing right now. I don't know why. I'm not. Hmm. Hmm. I'm confused. Okay. Let's go back to this. Well, this works like this. Actually, this might be kind of funny. If I call this function loop. And I do request an iteration frame loop. So I loop this. And then I also fill it with white. Um, this is how it works. I don't know. I don't see anything. I don't see anything. Oh, I didn't run it. Duh. Okay, I'll call it here. Okay, well, let's get rid of these things. Not really. I'm not very good at memorizing. Um, but for things that I use over and over, I will memorize it, or I will know how to derive it, like figure out what the formula is. But the idea is the more you use it, the tools are more closer to you. But the tools that I don't really use that often, they're just farther away from me. So I do forget things and I look it up. But the idea is, do you know where to look it up? Right? That's also very important. So let's say you encounter a concept. If you can name what that question is about, say, oh, this is a differential equation of third order, whatever that means. If you can name the beast, like give the question that you're looking for with a name, then you can look it up. And with internet these days, you don't need to carry books anymore. And you know, and in fact, I have a lot of papers and documents on my computer, and I can just look it up on my computer. And I write notes too to myself. So sometimes type up notes. That's also very good for yourself. So for example, I don't even remember how to make my draw a blank rectangle. So let me look this up, right? So for example, right now I want to clear the screen before I do this. So I will say, how to clear a screen. Basically, I need to draw a white rectangle, right? Clear canvas, HTML, JavaScript, right? And so this will do the job, I think. So maybe I just do this, right? Clear rect. We'll see what happens. Is it doing what I wanted it to do? It's probably in some weird loop right now. No, it's not clearing it. Doesn't do it. It's evolving something. So this doesn't work. I think it's probably just draw a You see, I'm kind of stuck. Full style, fill rec. Okay, let's try this. Fill style is not a function. Oh, right. Fill style is not a function. Fill style is just a variable. I don't see anything. That doesn't do what I wanted to do. Can I just do this? What's the proper usage of request animation frame anyways? Requests. Understanding request menu. I guess I could use set interval. Okay, hold on. Let me try set interval first. Because that I understand how it works. So let's see. First of all, does this work? Have a very good night. You should get some sleep. Okay, so it's doing stuff. It's doing random stuff. It's not a snowflake yet, but it's just demonstrating this coordinate system works. Okay. All right. Now initialize this board. So my question is, why does this part not work? What? Why is it only along these places? So confused. I'm so confused. Hmm. Well, if it's negated, it should be everywhere else, but it's not drawing. Somehow it's not drawing everything. That's what's concerning me. I should see 1,000 points on the screen. But why is it not drawing everything? Hmm. It's only plotting selectively. No, this works. Oh, Kim Wexler. Well, Hollywood. Magic of makeup. This is why people invent it, right? So Well, they say age is just a number, I guess. I don't understand why this is not working. This part works. This part works. So how am I calling this that is different here? Let's see. I and J, they're just numbers. Right? Unless this is not an integer. Do I need to parse int? No. I'll be very surprised if this is what I need to do. It is what I need to do. Oh, that is not an integer. Let me make a note. The index. Well, I hope you one day find that special someone. I believe everybody will. So let's see. So now I do this. I do this. I do this. Aha, okay. This is working as I wanted to. Got it. Got it, got it, got it, got it, got it, got it, got it. Okay, okay, I see. Let me call this more descriptive. Let's call it cell. 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 Okay. Still works. Okay. Perfect. Ah, wonderful, wonderful, wonderful. Okay. And can I call a cell 5, 1? So cell 5, 1 is true, but do I need to have quotes? 5, 1. It's interpreted the same way. How interesting. So that's interesting that the key is both a string and a, wow. Yeah, JavaScript is not that great because, I mean, that's the beauty of it. It's like, it's very ambiguous about its typing. But we'll just force it to parse it when we need to. Okay. So at least I understand how this structure works. Okay, okay. So let's call this subroutine drawing all cell states. Which I guess I do need to clear the board, which I believe we learned is to use this. right? Draw each cell states. Let's give this a name. Let's call this function draw. I hope I don't have a draw yet. Okay. And we draw here. All right, that's exactly what I wanted. It's running quite fast. Okay, I see coding. You see, I'm not a perfect coder. I'm not by any stretch of imagination good at all. But I just play around and mess around and I get stuff. Okay. So this is our test. We don't need this function anymore. Right. So I guess now I need a function. A function that detects the neighbor's cell states, and I will do it in counterclockwise order. So I do have a neighbor. I deleted a neighbor list. Okay, so that should be a constant. Okay. Oh no, why do I have a neighbors? Where's neighbors? No, I don't have a neighbor. Neighbor lists. Neighbor lists. Let's make it an object. The neighbor lists. So you got 0. Which I would do X and Y. Um, 1, 0. How does this work? Neighbor lists. So if I query 0, what do I get? Right, dot X, dot Y. Can I do dot 0? No, 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 no. But I probably can do X. I can do dot X. Interesting. Wait a second. Can I do cell dot 3? No, no, no. Okay, well, it was very finicky. Okay, well, that's fine. So that is neighbor list 0. 1, we will do, so 1 is this position right here. So it's 1 minus 1. Comma. Okay. 0, 1, 2 is this guy. 2 is this guy, which is 0, comma, y is -1. Why do you think that? Have you tried though? And if you haven't, you should try. And if you have tried, maybe change up strategy, maybe. I'm not sure. You know, sometimes though, I will have to say, people come into your life when you're least expecting, right? So sometimes if you're not even looking for them, they will just appear in your life, right? So maybe just let's kind of chance take over, right? And it's not iterable. Okay, interesting. Okay, so input is gonna be a position. It's gonna be of XY coordinates. And at the XY coordinate, I want to return a list of 6 things telling me whether it's on or off. So what I need to do is to return an array. Okay, so let's see. I will return an output array. Let's call neighbors. And for that I from 0, I less than 6, I plus plus. What do I want to do? I want to check cell XY. BDI equals to cell um 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 neighbor lists I dot x. Is that right? dot y. Okay. Okay, let's see if this works. Neighbors of 0, 0. It's all true. Oh, no, no, no. True, true, false, true, true, true. So at 0, 0, it should have, I have no idea where 0, 0 is. Where the hell is 0, 0? Where is 0, 0? Okay, I'm going to plot 0, 0 in blue. Just as a separate color. Default is black. But I can make it some color. Let's do 1, 1, 2, 2, 3, 3. I don't see it. Okay. Clear. Oh no, I see it. It's right here. So the neighbor should be true, true, false, true, false, true. True, true, false, true, false, true. So let's see. What is the neighbors? No. False, false. So it goes where? False, 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 false. True, false, true, false. False, false, true, false, true, false. There are two truths. But there are two empty lists. Oh, wait a second. I am plotting if if it's true, plot it. There we go. All right. So here there should be 5 truths and 1 false. Yep. True, 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 false. True, 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 false. True, 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 false. Yeah. True, 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 false. Good. Okay. It's kind of working. True, true, false. True, true, false. True, true, false. True, true, false. Let's see. True, true, false. True, true. Ah, okay. Excellent. Kind of works. I cannot see this color. I'm colorblind. So blue in X. Okay, so let's use this instead. Okey-doke. Aha. Okay. False, true, 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 true. False, false. Okay. And Blaine, you will find someone. I don't worry too much. You know, and in the meantime, distract yourself by doing, say, self-improvement, right? Go to the gym, maybe learn an instrument. I think people like people playing instruments, right? Learn a skill, be passionate about something, self-improvement, right? Focus on that. I believe in you. Okay, okay. This is kind of coming along. So now I have a function that will return an array of booleans. I need to give rules now. cycles. I need to okay, so here's a true test. If I ask, is this equal to true, comma, true, comma, true, comma, true, comma, true, comma, true, comma, true. How many truths do I have? 1, 2, 3, 4, 5, 6. If I ask this, of course it's not. But if I try to mimic this, true, false, 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 true, true, false, 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 true. So this is also false. So that is concerning. It's all about this reference that hmm. Is this really what I have to do? JSON stringify. JSON J. All right, that works. Let's play some very soft music.
Discovery Houston, press to ATO.
Liftoff of mission 41D, the first flight of the Ever Discovery, and the shuttle has cleared the tower.
Three, two, one, zero, liftoff.
Discovery, go and throttle up. Discovery's 4 computers now have primary control of critical vehicle functions.
Nice.
Liftoff of mission 41D, the first flight of the orbital Discovery, and the shuttle has cleared the tower. Discovery's core computers now have primary control of critical vehicle functions.
Nice. I think we have some sort of stability here. Okay. So what are all the configurations? I gotta draw this out. Is that all? So what's the number of ways of cyclically put 4 things in 6 spots? I think that's it, right? So there are 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So they are Okay, let's see what happens. It's doing something interesting. Okay, this is kind of working. It's doing something. Have we reached complexity? What does it look like at the end? It's kind of neat, I guess. Can I make it go faster? Oh, it's self-organizing into some sort of shape, starting from something random. So right now, what it does is it randomly chooses a particular configuration and decide randomly whether to melt or freeze, meaning add a point or delete a point for all the cells at each stage. So it's self-organizing according to very random rules right now. I can make it more systematic. Well, it's kind of neat. It's good progress. Okay. So let's see if we initialize M to just be one single crystal in the middle. Let's see what happens. So instead of initializing the entire board like this, so 0, 0, we'll give it a 1. So initially, I'm just gonna have one thing. Let's wait. Eventually, it should... Whoa, whoa, whoa. So it chose a rule. It does that. I should probably make a temp, so... Nothing's happening. Wait, what? Oh no. Why is it all gone so quickly? Gas comes in. Something interesting. Doing something interesting. Uncertain if that is the correct behavior, but I'll have to think through this. Okay, this is reasonable. Right? initial stages looks kind of interesting. The edge cases is really causing some aberrant behaviors. But as you can see, as it propagates, at some point it is nice. And then it stopped being nice. But if we force middle to always be on, At some point, it looks like a snowflake, right? Before it descends into chaos because of boundary conditions that cannot really. Oh, we don't have an infinite grid. That's the problem. So maybe I need to write a subroutine where I actually just simply make the boundary or like a hexagonal boundary that's just always empty. And in that case, we might be able to have a more consistent behavior for boundary conditions. Otherwise, because it's really right now, it is a parallelogram. Right now, it's fairly stable. Oh, now it gets crazy. The effects of the boundary condition reach the center. Okay, but I could now have a set of probabilities for each of the conditions and whether they freeze or melt. And select from a list that do that. Let's see if this is able to recover some sort of hexagonal structure. It's probably not able to. Well, so far I like the results. I don't know if we'll try request animation frame, I guess. Is that smoother? Doesn't look smoother to me. This is when it gets crazy. I guess it kind of oscillates. All right, I'll let this play a little bit. Let me take a break right now.
line D, the first flight of the orbital Discovery, and the shuttle has cleared the tower. Discovery's core computers now have primary control of critical vehicle functions.
Okay. So now let me implement more complicated rules. Let's see what we'll come up with. Let's see here. first. Much slower. There's a more complex rule. So now it takes all 13 patterns into consideration, but keeping always the first pattern, which is just having one neighbor. And also we have a rule of always having a center point. Let's see what happens. Hopefully by step 50, it will repeat. Did that? What happens here? Oh, it's not the cell problem. It's the seed problem. Now, do these look like real snowflakes? I think so. It's pretty convincing, right? Like snowflakes. You know, they look like this, and you know. Yeah, seems pretty convincing. So we have 2 to the 12 different ways of making these snowflakes right now. So that's about, what, 4,000? All right, here we go. I think this is pretty good, right? So different rules here will grow different type of crystals or snowflake. Some of these looks kind of messy, but there are some structures in some. Some of these looks really like snowflakes. All right, I think that is it for tonight. So hope you all have a good night.